Welcome to the TJ Cross Engineers Incorporated Process Safety Management Training Series. This training covers API RP14C, the recommended practice for the analysis, design, installation, and testing of basic surface systems for offshore production platforms. Although API RP14C was written for offshore facilities, this recommended practice is a very good guideline for preventing undesirable events for onshore facilities as well. An undesirable event is an adverse occurrence in a process component which poses a threat to safety and may be indicated by one or more process variables, ranging out of operating limits. The next few slides provide examples of undesirable events. Overpressure. Overpressure is pressure in a process component in excess of the rated working pressure. Leak. A leak is the accidental escape of fluids from a process component to the atmosphere. In this discussion, leak implies that the escaping fluids are hydrocarbons. Liquid overflow. Liquid overflow is the discharge of liquids from a process component through a gas or vapor outlet. Gas blowby. Gas blowby is the discharge of gas from a process component through a liquid outlet. Under pressure. Under pressure is pressure in a process component less than the design collapse pressure. Excess temperature for fired components. Excess temperature is temperature above that for which a process component is designed to operate. Direct ignition source for fired components. A direct ignition source is an exposed surface flame or spark at sufficient temperature and heat capacity to ignite combustibles. Excess combustible vapors in the firing chamber for fired component. Excess combustible vapors in the firing chamber are combustible vapors in addition to that required for normal ignition of either the pilot or main burner. All of the undesirable events that we just discussed initially present themselves as an abnormal condition. By properly reacting to abnormal conditions, we can prevent undesirable events. An abnormal condition is the symptom of an undesirable event. For example, high pressure is a detectable condition that indicates overpressure may occur. API RP14C uses both primary and secondary protection triggered by abnormal events to prevent undesirable events. Primary protection is the first line of defense against an undesirable event. For example, in the case of overpressure, a high-pressure sensor, also known as a PSH, will sense the abnormal condition of high pressure and shut off the inflow to stop the source of the pressure. Secondary protection is provided in case the primary protection fails. For example, in the case of overpressure, a pressure safety relief valve, also known as a PSV, will provide secondary protection by providing a means of outflow to alleviate the extra pressure. API RP14C provides guidelines for each type of equipment. For example, pressure vessels. Pressure vessels provide for separation, dehydration, storage, and surge. The guidelines provide us with typical pressure, level, flow, and temperature safety devices to prevent overpressure, overflow, gas blowby, and underpressure events. API RP14C provides a detailed safety analysis table, or SAT, for each type of equipment that outlines the possible causes of undesirable events and the detectable condition at each of the components. API RP14C also provides a safety analysis checklist to review design considerations for typical equipment and processes. The checklists make it easy to determine if equipment is adequately protected. A safety analysis function evaluation chart, or safe chart, is then developed to reflect the corresponding reaction of a safety device. Each process component is listed on the safe chart with its recommended safety protection in the first column. Shutdown and safety functions are listed on the top row. For each safety device, a specific shutdown or safety function is documented in the safe chart. Alternate protections or considerations are also documented. This guideline provides typical safety devices for a natural draft heater treater, which includes pressure, level, and temperature protection on the vessel. It also provides recommendations for temperature, pressure, and shutdown systems for the burner. This diagram shows typical protection for gauge setting test and group headers. Each header requires a pressure safety relief valve to protect the pipe against overpressure from blocked and misdirected flow. In this design, a pressure safety relief valve is installed to protect the flow line if the maximum allowable working pressure, also known as the MAWP, is less than the shut-in tubing pressure. Atmospheric tanks are usually protected with pressure safety relief valves, level controls, and a pressure vacuum safety valve, also known as a PVSV. Fired heaters are protected with nearly all types of safety devices. Waste heat steam generators heated with engine exhaust are protected with pressure safety relief, temperature switches, and low flow switches. Pumps are protected with backflow and low and high pressure protective devices. Compressors should be protected with pressure relief, temperature controls, and shutdown devices. Heat exchangers should be protected with pressure relief and temperature and pressure protection. Please refer to API RP14C for a comprehensive review of safety recommendations for typical upstream production systems. Appendix A contains a typical drawing showing the safety devices, a safety analysis table, or SAT, for each process component, and a safety analysis checklist, or SAC, listing all recommended safety devices and conditions under which a safety device can be excluded. This concludes our training module on API RP14C. If you have any questions, please contact our Mechanical Engineering group or our Process and Controls group for more information.